folks, welcome to Lab in Theory. This is the first of a series of videos that will dive into Matlab, a variety of applications to math and engineering. We'll start at the beginner level. We also plan on starting a series of other videos at the intermediate and advanced levels. Now, I'll try to keep these short, under 10 minutes, and basically do a deep dive into a variety of different subjects. So today's tutorial will cover the basics of Matlab. Just familiarize yourselves with it if you've never used it before. So let's get started. If you launch Matlab for the first time, you'll see something quite similar to what I have in front of me right now. Now this is the default layout. You have the command window in the center. If you hit enter, this is where you type in commands for the most part. The left-hand side shows the current folder and all of its files and contents. The right-hand side is your workspace. This will show you all the variables that you have defined in the current session, unless you clear them, which we'll look at in a little bit. I like to change my layout a little bit. I like to go down to the command history and dock it right here. So this will show a history of the commands I typed in. Useful if I close a session or my computer restarts or crashes and I want to go through a series of commands that I typed in earlier. So let's get started. The first thing to keep in mind is that operations in Matlab are matrix operations by default. So the same rules of linear algebra apply. Now, I'm going to assume you have at least a basic understanding of matrix math and introductory level linear algebra. And if not, you can kind of pick it up on the fly, hopefully. So what I'm going to do is define a variable here. I'm going to call it xi. I'm going to set it equal to, I open a square bracket, 0.3, 0.4, 0.2, and 0.1. Notice that when I hit enter, a few things happen. Matlab echoes back out what I typed into it right here. The workspace now has a variable called xi defined in it, and my command history shows that last command I typed. Now, if you want to suppress what Matlab, the echoing behavior, I just press the up arrow. I can enter a semicolon, hit enter, and voila, nothing happened. One important thing to note is that by default, what I just typed in here is a row vector. And this is important when doing basically linear algebra and matrix operations. So let's define a second vector. We'll call it P equals 50.3. And notice how I'm omitting the comma here. MATLAB will take in values either way, but I prefer to put the commas in there for safety. 36.1, and I'm going to put a little apostrophe, and what that does when I hit enter is it actually creates a column vector right here. So row vector xi, column vector p. Now suppose I wanted to multiply every element of xi by every element of p. You'd think that just by typing xi times p it would do that, but what I get is a single value here. And this is the result of Matlab performing an inner product or dot product on these two vectors. Now this is again the default behavior of Matlab because Matlab assumes operations entered are of the matrix form. Now if I wanted to multiply the elements one by one or an element by element operation, I use the dot operator. Now what I'm going to do is I'm going to take xi, transpose it again because we want the two dimensions to match, and we'll look into that in a little bit deeper. Then a period times p, hit enter, and now we have gotten back a column vector containing the element-wise multiplication of these two vectors. Now, why did I transpose xi? Well, whenever you do an element-wise operation, the two dimensions of the arrays that you're working with have to match. So if I were to type in the opposite, say xi dot times p transpose, I will get the same values, but the result will be a row vector. Now, in this case, it doesn't matter so much, but whenever you're trying to compose larger objects and multiply by matrices and things get more complicated, this actually makes a big difference. Now, the next thing we'll look into is the matrix left divide operation built into Matlab. Now, this is very important, so I'm going to switch screens over here real quick. I wrote up a small, simple system of linear equations right here. Notice I have the variables x1, x2, x3, and x4 in blue, and then all of the coefficients in black and the equalities on the right-hand side. Now, this will let us take a look at typing in a matrix into Matlab. So I'm going to type in CLC. What that does is it clears my command window. It didn't actually wipe anything from memory. My workspace still has my 3 variables. And by the way, answer is the very last answer that Matlab computed if you did not assign the computation to a variable. So let's type up the system of equations. So we want to solve for the 4 unknowns. What we'll do is we will again extract all of these coefficients into a matrix, create a vector on the right hand side, and attempt to solve for the unknowns x1 through x4. Now, to do that, I'm going to define A equals, open a square bracket, and then I'm going to type in the coefficients. So 20, 39, minus 40, 10, and then I'm going to enter a semicolon. What that means in Matlab, when I am inside of a definition, it means a new row, basically. So this is going down to the second row. So 25, 23, 33, negative 36, another semicolon, 38, 14, negative 22, 9, semicolon, 6, negative 25, 48, negative 18. I'm going to close that, and I'm just going to hit enter to show you exactly what that looks like. So again, we have a matrix right here. So it's 4 by 4 with all of our coefficients. B is going to be all of our right-hand side. So that's 18. Now, I'm going to do something different. I could type them all up like this with commas and then transpose. Or I can actually put a semicolon. So that's a single value. Semicolon gives us a n by 1 matrix or a column vector. So 18, 26, 36, 28. There we go. Now, how do we solve for x? So the equation ax equals b. In Matlab, that's very simple. You type x equals a backslash b. And there you go. There's the result. 1, 2, 3, 4. Now, this is a simple example, but it illustrates the power of the backslash operator in Matlab. It doesn't just solve for, which is essentially inverting A, multiplying it by B, though it probably uses something slightly different internally. It's actually quite powerful and handles underdetermined and overdetermined systems as well. And again, we'll have another session and dig into that a little deeper. So one last command I wanted to teach you, which is clear, and what clear does is it actually removes a variable from memory. So if you take a look at xi right here, which we used before, if I type in clear xi, xi is now gone. If I type clear all, my entire workspace is empty, and then if I type clc, that clears out my command window. So this brings us to the end of today's video. I hope you enjoyed it and learned a little bit about Matlab. If you liked it, please give it a thumbs up. If you'd like to see more, please subscribe. Of course, leave comments down below. Let us know what you're interested in learning about, what you're interested in seeing, and we'll hopefully make you a video. Thanks again for watching.